Welcome to this another video of Internet connectivity principles and application protocols for IoT. Reference for this video is Internet of Things by Raj Kamal, and another reference book is Internet of Things Systems, Architectures, Algorithm, Methodology. So the contents of this video are internet connectivity, communication, overview of protocols like IPv4, IPv6, 6LoWPAN, then basics of application protocol like MQTT and CoAP. So in previous videos I have covered basics of application protocols like MQTT and CoAP, and with their features, framework, message format, implementations, and applications. So in this video we will basically talk about internet connectivity, the communication, and overview of IPv4. Right, so let's begin with the first point, that is internet connectivity. Now here in this video we will discuss how to connect to the internet, that is internet service providers, software and hardware requirements, and configuring internet connection, etc. So Internet Service Provider, in short called as ISP, is a company offering access to internet. They offer various services such as internet access, domain name registration, dial-up access, and lease line access. So with those services, let's begin with different types of ISPs that we should consider. ISPs can broadly be classified into 6 categories, which are shown here. Now this internet service provider is divided in 6 categories such as access providers, mailbox providers, hosting ISPs, virtual ISPs, free ISPs, etc. Now in this, access provider means they provide access to internet through telephone lines, cable, Wi-Fi, or optical fibers. The next is mailbox provider. Such providers offer mailbox hosting services. Next is hosting ISP. Hosting ISP offers email and web hosting services such as virtual machines, clouds, etc. Then virtual ISP. In virtual ISP, these are the ISPs in such a way that ISPs offer internet access via other ISP services. And the last one is free ISP. Free ISP do not charge for internet services. So here are some of the connection types. So there exist several ways to connect to the internet. These are the connection types available. Number 1 is dial-up connection. Number 2 is ISDN. Number 3 it is DSL. Number 4 cable TV internet connection. Number 5 satellite internet connection. And number 6 is wireless internet connection. So let's describe those different types of connections in detail one by one. So dial-up connection. Dial-up connection uses telephone lines to connect PC to the internet. It requires a modem to set up dial-up connection. This modem works as an interface between PC and the telephone line. So there is also a communication program that instructs the modem to make a call to a specific number provided by an ISP. So dial-up connection uses either of two protocols, in which number one is serial line internet protocol, in short SLIP. Number two is point-to-point protocol, in short triple P. So this following scenario, following diagram shows the accessing internet using modem, in which we have a computer over here which is connected to a modem. Through an antenna, it is connected to another modem through the internet, and it is connected with the computer. So the communication between computer to modem is carried out in digital signaling. Modem to antenna, the communication is on analog signals. And finally, at the end, modem to computer, the signals are digital signals. Next one is ISDN. ISDN is an acronym of Integrated Services Digital Network. It establishes the connection using the phone lines which carry digital signals instead of analog signals. There are two techniques to deliver ISDN services. First is basic rate interface, in short BRI, and second one is primary rate interface, in short PRI. The key points to be considered here are: the BRI ISDN consists of three distinct channels on a single ISDN line, that is 64 kbps channel and one is 16 kbps channel. The PRI ISDN consists of 23-bit channel and 1D channel, with both have operating capacity of 64 kbps individually, making a total transmission rate of 1.54 Mbps. This scenario shown here describes accessing internet using ISDN connection. So the only change here is, instead of modem of dial-up connection, we require here ISDN adapter. So computer can get connectivity to another computer through ISDN adapter and the internet. Next is DSL. DSL is acronym of Digital Subscriber Line. It is a form of broadband connection as it provides connection over ordinary telephone lines. There are several versions of DSL techniques available today. In that, first is asymmetric DSL, that is ADSL. Second is symmetric DSL, that is SDSL. Next is high bitrate DSL. Then fourth is rate adaptive DSL. Fifth is very high bitrate DSL. And the last one is ISDN DSL. So all the above mentioned technologies differ in their upload and download speed, bit transfer rate, and level of service. The diagram shown here is describing how we can connect to internet using DSL technology. So we have a set of computers connected with the router. Router is connected with the modem, and modem through internet connected to other DSL modem, and DSL modem is connected to end user. So next is cable TV internet connection. Cable TV internet connection is provided through cable TV lines. It uses coaxial cable which is capable of transferring data at much higher speed than common telephone lines. Key points to be considered here are: a cable modem is used to access this service provided by the cable operator. The cable modem comprises of two connections, one for internet service and other for cable TV signals. Since cable TV internet connections share a set amount of bandwidth with a group of customers, therefore data transfer rate also depends on number of customers using the internet at the same time. The diagram shown here describes how the internet is accessed using cable TV connection. So to our computer or to the TV, we have connected cable modem and cable TV converter, which is ultimately getting input from splitter, and splitter is connected to the node. So this node is connected to the internet. Next type of connection is satellite internet connection. Satellite internet connection offers high-speed connection to the internet. There are two types of satellite internet connections: one-way connection and two-way connection. In one-way connection, we can only download data, but if we want to upload, we need a dial-up access through ISP over a telephone line. In two-way connection, we can download and upload the data by satellite. It does not require any dial-up connection. So diagram shown here describes how internet is accessed using satellite internet connection. Next point is wireless internet connection. So wireless internet connection makes use of radio frequency bands to connect to the internet and offer a very high speed. The wireless internet connection can be obtained by either Wi-Fi or Bluetooth that we have discussed in previous videos. So the points to be considered here are Wi-Fi technology. Wi-Fi wireless technology is based on IEEE 802.11 standards, which allow the electronic device to connect to the internet. Another one is Bluetooth wireless technology, makes use of short wavelength radio waves and helps to create a personal area network, that is PAN. Now let us move on to the next point, that is overview of protocol. In that, first we will discuss IPv4, Internet Protocol version 4. So for that, let us talk about the tutorial or the video first. Internet Protocol version 4 is the fourth version in development of Internet Protocol and the first version of protocol to be widely deployed. IPv4 is described in IETF publication, replacing an earlier definitions. So this video will help you in understanding IPv4 and its associated terminologies along with appropriate references and examples. So the audience who are appropriate for this tutorial, the tutorial has been designed to help beginners understand basic concepts of IPv4 required to work with any TCP/IP based protocol. After completing this, studying this concept, you will find yourself at a moderate level of expertise of IPv4, from where you can take yourself to next levels. The things we should know before we start with the concept, that is prerequisites. So before you start proceeding with the video, I'm making an assumption that you are already aware of basics of computers and network concepts such as what is protocol, why do we need a protocol and network layers, etc. So let's begin with this IPv4 overview. This IPv4 is said to be the era of computers. Computers have significantly changed the way we live. A computing device, when connected to other computing devices, enable us to share data and information at lightning fast speed. So let's understand what is network. A network in the world of computers is said to be a collection of interconnected hosts via some shared media which can be wired or wireless. A computer network enables its hosts to share and exchange data and information over the media. Network can be a local host, local area network spanned across an office, or metro area network spanned across a city, or wide area network which can be spanned across cities and provinces. A computer network can be as simple as two PCs connected together via a single copper cable, or it can be grown up to the complexity where every computer in this world is connected to every other, called the internet. In network then include more and more components to reach its ultimate goal of data exchange. So here are some of the brief descriptions about the components involved in computer network. So first is hosts. Hosts are said to be situated at ultimate end of the network. That is, host is a source of information and another host will be the destination. Information flows end to end between the hosts. A host can be a user's PC, or it can be internet server, or it can be a database server, etc. Next is media. If wired, then it can be a copper cable, fiber optic cable, or coaxial cable. If it is wireless, it can be free to air radio frequency or some special wireless band. Wireless frequencies can be used to interconnect remote sites also. Next component of network is hub. A hub is a multiport repeater and it is used to connect host in a LAN segment. Because of low throughput, hubs are now rarely used. Hub works on layer 1, that is physical layer of OSI model. Next is switch. A switch is a multiport bridge and is used to connect host in a LAN segment. Switches are much faster than hubs and operate on wire speed. Switch works on layer 2, that is data link layer, but layer 3 network layer switches are also available. Next is router. A router is a layer 3 network layer device which makes routing decisions for data or information sent for some remote destination. Routers make the core of any interconnected network and the internet. Next component is gateways. A software or a combination of software and hardware put together works for exchanging data among networks which are using different protocols for sharing data. Then firewall. Firewall is a software or combination of software and hardware used to protect users' data from unintended recipient on the network or internet. All components in the network ultimately serve the hosts. Next point is host addressing. The communication between hosts can happen only if they can identify each other on the network. In a single collision domain, where every packet sent on the segment by one host is heard by every other host. So host can communicate directly via MAC address. MAC address is a factory coded 48-bit hardware address which can also uniquely identify a host. But if a host want to communicate with a remote host that is not in the same segment or logically not connected, then some means of addressing is required to identify the remote host uniquely. A logical address is given to all hosts connected to internet, and this logically address is called as internet protocol address. Next is the OSI model. The International Standard Organization has a well-defined model for communication system known as Open System Interconnect or the OSI model. This layered model is conceptualized view of how one system should communicate with the other using various protocols defined in each layer. Further, each layer is designated to a well-defined part of communication system. For example, the physical layer defines all the components of physical nature. That is, wires, frequencies, pulse codes, voltage transmission, etc. of a communication system. So OSI model has those 7 layers, in which application layer, that is layer 7, this is where the user application site that needs to transfer data between or among the hosts. For example, HTTP, File Transfer Application Protocol, FTP, electronic mail, etc. Next is presentation layer, that is layer 6. This layer helps to understand data representation in one form on a host to other host in their native representation. Data from the sender is converted to on the wire data general format, and at receiver end it is converted to native representation of receiver. Next is session layer, that is layer 5. This layer provides session management capabilities between the hosts. For example, if some hosts need a password verification for access and if credentials are provided, then for that session password verification does not happen again. This layer can assist in synchronization, dialog control, and critical operation management, that is online bank transactions. Next layer is transport layer, that is layer 4. This layer provides end-to-end data delivery among hosts. This layer takes data from the above layer and breaks into smaller units called as segments and then gives it to the network layer for transmission. Next one is network layer. It is layer 3. This layer helps to uniquely identify hosts beyond the subnet and define the path which the packets will follow or be routed to reach the destination. Then second layer is data link layer. This layer takes the raw transmission data, that is signals, pulses, etc. from physical layer and makes data frames and send that to the upper layer and vice versa. This layer also checks any transmission errors and sort it out accordingly. And the layer 1 is physical layer. This layer deals with the hardware technology and actually communication mechanisms such as signaling, voltage, cable type and length, etc. Now the point to be noted here is network layer. Network layer is responsible for carrying data from one host to another host. It provides means to allocate the logical address to host and identify them uniquely using the same. Network layer takes data from transport layer and cuts them into smaller units called as data packets. Network layer defines the data path the packet should follow to reach to the destination. Router works on this layer and provide mechanism to route the data to its destination. Now, here is the TCP/IP model. A majority of internet uses a protocol suite called as an Internet Protocol Suite, also known as TCP/IP protocol suite. This suite is combination of protocols which encompasses a number of different protocols of different purpose and need. Because the two major protocols in this suite, that is TCP, that is transmission control protocol, and IP, that is internet protocol, this is commonly termed as TCP/IP protocol suite. This protocol suite has its own reference model which it follows over the internet. In contrast with OSI model, this model of protocol contains less layers. So you can observe the difference, a comparative depiction of OSI and TCP/IP reference model. So this model is indifferent to the actual hardware implementation, that is the physical layer of OSI model. This is why this model can be implemented on almost all underlying technologies. Transport and internet layers corresponds to the same peer layers. All three top layers of OSI model are compressed together in single application layer of TCP/IP model. So let us move on to Internet Protocol version 4, that is IPv4. Internet Protocol is one of the major protocol in the TCP/IP protocol suite. This protocol works at the network layer of OSI model and at the internet layer of the TCP/IP model. Thus, this protocol has responsibility of identifying hosts based upon their logical addresses and to route data among them over the underlying network. IP provides a mechanism to uniquely identify hosts by an IP address scheme. IP uses best effort delivery, that is, it does not guarantee that packets would be delivered to the destination host, but it will do its best to reach the destination. Internet Protocol version 4 uses 32-bit logical address. Now let us understand IPv4 packet structure. Internet protocol being a layer 3 protocol of OSI takes data segment from layer 4, that is transport, and divides it into a packets. IP packet encapsulate a data unit received from above layer and add to its own header information. So IP encapsulation is shown here. To encapsulate data is referred to as IP payload. IP header contains all necessary information to deliver the packet at other end. So IP header is shown here in this figure. So IP header includes many relevant information including version number, which in this context is a 4-bit, and some of the others are described here. Number 1, it is version number of internet protocol used in IPv4. Next is IHL. IHL describes the internet header length, that is the length of entire IP header. Next is DSCP. DSCP indicates a differentiated services code point. This is a type of service. Next is ECN. ECN is explicit congestion notification. This carries information about the congestion seen in the route. Next is total length. This total length is length of entire IP packet including IP header and IP payload. Next is identification. If IP packet is fragmented during transmission, all the fragment contain same identification number. To identify original IP packet they belong to. Next is flags. As required by network resources, if IP packet is too large to handle these flags, tell if they can be fragmented or not. In this 3-bit flag, the MSB is always set to 0. Next is fragment offset. This offset tells the exact position of the fragment in the original IP packet. Next field is time to live. To avoid looping in the network, every packet is sent with some TTL value set, which tells the network how many routers, that is hops, this packet can crosses at each hop. Its value is decremented by 1, and when the value reaches to 0, the packet is discarded. Next field is protocol. This tells the network layer at the destination host to which protocol this packet belongs to, that is the next level protocol. For example, protocol number of ICMP is 1, TCP is 6, and UDP is 17. Next field is header checksum. This field is used to keep checksum value of entire header, which is then used to check if the packet is received error free. Next field is source address. It is 32-bit address of the sender or source of the packet. Next is destination address. It is 32-bit address of the receiver or destination of the packet. The last field is options. This is optional field which is used if the value of IHL is greater than 5. These options may contain value for options such as security, record root, timestamp, etc. So this is the end of the video. So thanks for watching this video.